screen to you. Okay, you can see that. Now let's see. Okay. So you can see the screen here. You can see my screen, yeah? Good. Yes, you can. Okay, that's good. Right. So first I'll show you the questions. Right, these questions in the exercise, which page is this? Page 42. Because after this exercise, there will be the appendix, yeah? Appendix A and appendix B. So what we want to do is to go through exercise 1 until 8 for this morning. And maybe some of the time we go to from 9 to 13. Yep. So question number 1. Bunga Kintan is our hypothetical ship that we have seen in chapter 2, hydrostatic data given chapter 2. So we are going to refer to this later when we go to the other chapters as well. We're going to refer to Bunga Kintan. So it is now floating at draft of 6.5 meters. If its kg is 6.8, what is its gm? I think I made a mistake here. Wait a minute. Right. Okay, I made a mistake. It's supposed to be 6.25. Yeah, because 6.5 is too easy. So the question should be 6.25 here. 6.5 is too easy. Right? Okay, so that is the question. So I copy the question here to the top of my Excel file, and I hope you can see the Excel file as well. We make it slightly bigger. Also, this one. Right. So that's Bunga Kintan given floating at draft of 6.25 meters, yeah? 6.25, it's not 6.5. All right, so the question is, if its kg is 6.8, what is its gm? It's a very simple question, but it is actually trying to see whether you understand what is hydrostatic particulars, what are hydrostatic particulars, okay, from chapter 2, and whether you understand the relationship between Kb and Bm, MBMT, and KMT, yeah, so and GMT. So that relationship is very important. So we want to see it here. So this is a copy of the hydrostatic particular from Bunga Kintan. The way it says it's floating at draft 6.25 meters, automatically you go to this the hydrostatic particulars and see, oh, there's not 6.25 is not given here, right? So it's only given in 6, 5, 5.5, 6, 6.5, 7, 7, so on. So automatically it comes to your mind, you did interpolate, yeah, to get the hydrostatic particulars for these sections, right? So you need to interpolate that. So given draft of 6.25 meters, find the hydrostatic particulars at that draft. So what you do, of course, at 6.25, you interpolate. It is, of course, in between 6 and 6.5. So this one is 6.5, 6.25. Then you can interpolate. This is basically halfway. So this plus that divide by 2. So you get that. But the data that you're interested in is not the rest. It's only are only these two, KB and BMT. Because KB plus BMT becomes KMT. Yeah. So to find GM, we need KMT so that we can use the formula KM is equal to KB plus BMT. So you add these two, you get 7.985. And also KMT is also equal to KG plus DMT. All right. So it is given KG is 6.8, therefore DMT is 1.185. So quite easy enough. So the main point that you need to remember is how to use the hydrostatic particulars to get Kb and Bmt so that you get Kmt, and then how you calculate to this formula that Gm is Kmt minus Kg, which is this particular formula. So use these two formula, right? So that's number one. Number two. So that's a question for number two. So the question says a ship displacement 1,800 tons and kg is 3 meters, loads cargo at kg 2.5 meter and 400 tons bunkers at kg 5 meters. Find the final kg. So this is very similar to the example in the notes, right? So always when we have this kind of thing, we need to make this table. So this table is called loading table. So very important to make loading table, yeah? So this is a loading table. And in the loading table, you need to have at least two things. One is the original ship and its kg. And secondly will be whatever that you add or you remove. In this case, it says that load. Load means you add. So load 3,400 and load 400 tons. And bunker is same as fuel. So when the ship is bunkering, it means it is refueling. So this spelling here, it means it is refueling, bunkering. So when a tanker is bunkering, it means it's refueling, it's adding fuel to it. Yeah. In this case, fuel is loaded up for the trip, so the positive sign. So in this case, 400 tons has been loaded, so it is positive sign here. If you use the fuel, then it becomes negative. That means you reduce the weight from the ship. So you need to have the item. The first item is original ship. And then these are the things that's loaded or unloaded. Okay, and then you have the final one. So the final, of course, is the sum of this, 5,600. And then you have the kg for each respective item. So for the ship, kg is 3 meters. For the cargo, kg 2.5. For the bunker, kg 5 meters. So you multiply this by this, you get that. This by this, you get that. So you sum up the moment. So this is sum of moment. This is sum of weight. Finally, the kg is final total moment divided by final displacement or final weight. Displacement weight same, it's in tons. So you divide, this is in ton meter, divide by ton, so you get meter, 2.84 meter. So we note that the addition of heavy cargo whose kg is lower than the original kg has reduced kg, or the bunker is added at higher position, it is comparatively small. So like this, you see the kg has been reduced. Original ship 3, now 2.84. Why is it reduced? Because the cargo is added lower than the original kg. And big cargo, 3,400. So although the fuel was added above the original kg, the ordinary G, the weight is not so big, so the moment is not that big. So this moment, we should reduce the center of gravity, is better. So for a ship, always lower center of gravity is better because Km is constant. Okay, so if you have a lower center of gravity like this one, then you have bigger GM. Yeah, always we want to have big GM. So the spacing between Kg and Km, okay, is GM. So if you have low Kg, then you have better stability. Question number 3. Again, it is almost similar question. I need to look at it again, so I need to open this one. Right? So a ship sailed with a displacement of 3,400 tons and kg 3.75. During the voyage, bunkers were consumed as follows. Okay, bunkers were consumed. That means fuel were used. Okay, 66 ton at this kg and 64 ton. Then they have a few tanks. So from one of the tanks, 66 ton was taken. The other tank, 64 ton was taken. So what happened to the kg at the end of the voyage? That's the question. All right. So same thing, you make this table. You make this table, the original ship. Okay, and then you have bunker one. Bunker one is, we don't know which tank is it, but that first item of that bunker, I said bunker one. So it is minus 66. Remember this, because you remove, yeah. In this case, fuel is used up during the trip, so negative signs are given to unloading or the removal of the bunker, right? So fuel used up, so bunker is reduced by this much. Sorry, the weight is reduced by this much, right? So at this kg, that's given in the question. So you can get the final weight to be 3,200 and the final moment to be 12,000. So you divide that, you get the final kg of 3.87. So notice that here, the removal of the bunkers during the journey has increased kg, because the weight being removed are from below the original G. This is the original G, 3.75 kg. And then you remove the weight, the bunkers below it. So when you remove something from below the original G, the G will move up. If you add at the location below the present G, G will move down. If you remove, G will move up. So remember that. Right, so that's number 3. Question number 4. Question number 4. A ship had displacement 1,000. Now, basically, it's just a ship that has so many things. You add here, to add there, and so on. And then when it arrives to port, it loads that. It loads this many cargo and bunkers, and then she discharged 2,000 tons of cargo. Discharge means to remove, yeah, to remove. Discharge 2,000 tons and consume. Consume means also to use 900 tons of fuel during the voyage, right? So if km is 5.5, find the final GM arrival at port of destination. Yeah. I don't know why is this kg 1 meter here. Is there something wrong there? The 64. I think that question was wrong. It was not. Okay. I think I copied that and I did not delete that the end there. Just this one can be removed at the end, yeah. kg. This was a leftover from the previous question because cut and paste. Right, so that's the question. Find final GM on arrival at port of destination. Okay, as usual, make this table. This is a loading table. Okay. So when you load something, it's positive. When you unload or used or consume, right? So it is. We put negative here. So the ship is loaded with cargo and bunker in the port of departure. Throughout the trip, it consumes 900 tons of fuel here. On arrival at destination, it unloads part of the cargo, which is minus 2,000 here, the 2,000. So we can find its final kg, and if we know km, we can also find gm. So same thing, make the same table, similar thing. This is positive because it's added at the beginning of the trip. And then when on its arrival at the port destination, it unload 2,000 tons. And during the trip, bunker during the trip is 900 tons minus. So you get this to be the minus of the moment. So again, the same thing, get the kg finally. And since we know km is given at 5.5, so gm is km minus kg, 1.45. Okay, this one is not necessary, yeah? But although we can say that because it's also removal of cargo. this is not part of the question, but it's still applicable, yeah, still applicable. Okay, question number 5. I'll go through later. You can, if you want to come back to any of the question, we can come back. Question number 5 is a long question like this. A ship arrived in port. It arrived with this displacement and kg, and then she discharged and load. Discharge means unload. Yeah, discharge. The word discharge, unloaded, and consumed have the same meaning. That means the weights are removed from the ship and must be given negative signs. This is negative sign. Yeah. So that means this one is negative. The load are positive. And then during the stay in port, while it is loading and unloading, it also use 30 tons of oil. Kg, 1 meter. Okay, so it's consumed. So if final km is 6.8, what is gm on departure? So after, when it's about to depart, it has done all these things. It discharged this, it unload this, and it use fuel. So you make a big table like this. Same thing. You don't ever forget the original sheet. Okay. Then you put whatever cargo. So I call it cargo 1, cargo 2, cargo 3. Okay. So with all the numbers here. And because this is unloading, so it is minus. So this is load. So you load cargo 1, cargo 4, cargo 5, and bunker. You load bunker and also fresh water. Right. So this is bunker import. Is considered as unloading as well of 30 tons. So we see the question. Okay, during stay import, 30 tons of oil are consumed. So 30 tons of bunker lah. Bunker is the same as oil, the oil being used, being burned. Right. So there we have. This is the total moment, and again find the kg. And given km is 6.8, gm is 1.2. So quite easy. Number 4 and number 5 almost similar, just that these have more loading and unloading compared to number 4 here. Same thing, yeah. So this is number 4. So almost copy that. Right. So number 4, number 5, same one. Number 6. Number 6 is more of adding and movement of weight on board ship. Yeah. So like this one, for example, a ship 9,500 tons displacement has km 9.5 and kg 9.3. So km 9.5, kg 9.3. A load 300 tons on the lower deck. Say this is the load. It can also be here. It doesn't matter. The ship is not balanced. So now you move weight load here from here up here. A distance of sorry. So it's okay. Now I made a mistake in this question. Yeah. Here the kg for this load is how many? 0.6 meter. Right? 0.6 meter. So and then it move here. Kg here is sorry. Kg at this point is 11 meter. Okay, so I made a mistake also here. So g dash. So because of the weight move up, say this is the original g. This is g without dash. Okay, this is original g. G without dash. Yeah, this is the original g, and it moved. So this is not correct. The actual movement here is not 11 meter. This is only 10.4 meters. How do you get 10.4? Because this is 11 meter minus 0.6. The actual movement of center of gravity is 11 minus 0.6, so 10.4. Right? So GG dash is the increase in center of gravity. Okay, that small amount is weight move times distance move divided by ship displacement. So this is, this one is wrong, eh? This is 10.4. So 0.33 meters. And the original kg was given as 9.3. So the new kg is the original 9.3 plus 0.33. Yeah. So that means the new GM, okay, is KM has not changed because there is no change in weight on board. No change, no addition of weight. There is no addition of weight, there is no change of hydrostatic particulars. KM is constant when the draft doesn't change. So in this case, draft should not change because it is a weight on board already on board, yeah? So since there is no change of total weight, displacement and draft, so the KM remains at 9.5. So 9.5 minus 0.3, 0.13, sorry, minus the origin, the new center of gravity kg. So the GM becomes negative. Yeah. So note that the movement of weight from the lower deck to the upper deck has increased kg such that it is higher than km, resulting in negative GM. This situation is dangerous and the ship may capsize. So GM must always be kept positive. Yeah, in fact, okay, this one you can take a note. I put a note here. Okay, according to IMO, International Maritime Organization rules, which you are going to learn in the Navigation 2, GM should not be less than 0.15 meters. So that is what IMO has said as the safe GM is that GM should not be less than 0.15. For normal, typical merchant ship, yeah. For fishing vessel, it's bigger, 0.3 or 0.35. But for commercial vessel, it is 0.15. So whenever you find your calculation shows that GM is less than 0.15, you can automatically make a judgment that this is not acceptable. You need to change your loading and so on, so that you get more than 0.15. So in this case, it's not only less than 0.15, but it's negative. Definitely, it is unacceptable. So if this were to actually happen on board a ship, yeah, if the captain did this without, or order this to be done without doing calculation, the ship will capsize. Yeah? So that's why it is important for ship crew to be able to understand and calculate the stability of the ship along the way, yeah, during operation. Number seven is it is almost similar. No, it's almost similar. Still, it's about movement of weight, but it's asked in a kebat way, kebat, higher order thinking. So, something like you need to understand what's happening. A ship 4,500 515 tons displacement is upright and has kg of 5.4. And km 5.5, it is required to increase gm to 0.25, or weight 50 tons is shifted vertically for this purpose. Find the height through which it must be shifted. So if you do not, always in our naval architecture work, always sketch. Okay, if you see when there are questions like this, if we sketch it, we can understand. Like this now, when I sketch it now, I remember that it is not 11 meter, the movement of this, but it's only 10.6 meter, 10.4 meter. Yeah. So like this one also, if you sketch it, then you can understand what's happening. So what's happening here is, originally, km 5.5, gm is 0.1 because kg is only 5.4. Okay. Km 5.5, kg 5.4, so GM is 0.1. That's original condition, like this. So the captain says, wow, this is not good, 0.1 meter. We need to increase. So he decided to increase it to 0.25 meters. He said, okay, let's increase GM to 0.25. And he wants to increase that by moving weight already on board. So moving weight. So naturally you need to think, which way should it move? Say if there is a weight here, well, the weight could be anywhere. We want to move it such that it is, say there's a weight anywhere, whether it needs to go up or down. When you want to increase GM, you have to reduce kg. If you want to reduce kg, you need to move the weight down so that G can move to G dash, which is lower. So that's basically the solution here. What he wants at the end of this operation is that G dash to M, which is a new center of gravity to M, is 0.25. The original one is 0.1. G to M at the moment is 0.1. Yeah. So this one is 0.25. So the movement G to G dash that is required is 0.25 minus 0.1. Okay. So that's what we do. The original kg is 5.4. Km is 5.5. So the original GM is 0.1 meter, which is very small. So there is a need to increase to 0.5. To increase GM, Km cannot be changed because you are already floating at that draft. So only kg can be reduced slightly so that the GM can increase. So kg need to be increased. So shift of the center of gravity is parallel to line of movement center of gravity to which the weight is being moved. This is the rule. So when you want to shift center of gravity, you move the center. If you want to shift it down, you move the weight down. If you want to move the center of gravity up, you move the weight up. You want to move the center of gravity to the right, you move weight to the right. So like that. That's how you. So in this case, to increase GM, kg must be reduced, lower kg. So the reduced center of gravity, the weight has to be moved downwards. Remember that. So how much is required to the movement? The movement required is GG dash. So that finally the GM, so this is G dash M, okay, is 0.25. So GG dash is 0.25 minus 0.5, 0.15. I've shown that one. 0.15 is the difference between 0.25 and 0.1 here. So the red one is basically 0.15. So I can put here 0.15. The red part. Make it smaller. So that's 0.15, the red portion, right? Because there's 0.1 there. Okay, so with that, that GG, that 0.15 must be the same as the weight moved times h. H is the unknown. How far is the movement of the weight? How far is it going to go? How far down? Yeah. So finally we get the h to be 13.55. All right. So that's basically the idea about this question. Yeah. And finally, for the last question, 8. A ship 7,500 tons, displacement has kg 5.8 meter, GM 0.5, a weight of 50 tons is added to the ship, location kg 11 meter and 7 meter from center line to the starboard side. Find final location of G above keel from the center line. So again, always sketch it out. Basically what's happening. Let me make it smaller first. So if this is the shape, okay, this is the shape. Take border outside there. Okay. So a weight 50 tons. So this is starboard, this is port. So it's added to the ship location kg 11 meter, right? So kg 11 meter. So this height is 11 meter and 7 meter from the center line. So this is the center line here. So this is 7 meter. I call it D here, and I can call it H here, right? On the sum, find the final location of G above keel and from the center line. What is the new GM? Okay. So when a weight is added here, G moves towards the point of addition. Okay, so if you draw a line from G to that point, so this is the line, so G moves towards that. And if you remove weight from here, G will move away from that point of addition. Yeah. So in this case, you add, so it goes to G dash here. So the question is, it asks how far from the center line is the G dash and how far high it goes up. Yeah, this way. Or because it asks find the location of the final center of gravity. So we can do that by doing it in two movements. It moves here, all right? Or it can move up here to the right. So movement to this side is because of this distance, this moment from the center line here. Okay, and movement in the vertical direction if you take moment about keel. So in this case, we don't have to take moment from keel. We just use the formula in the appendix B, appendix B about movement of weight, which we have seen before. That means when weight is placed on one side, G moves to G dash. G moves to G dash. The movement can be seen in two stages. Okay. First, G to G dash. G to G double dash. And then from G double dash to G dash. Right? So, we call it X and Y. The vertical G dash, G to G double dash, we call it X. G double dash to G dash, we call it Y. Okay, so X is G double dash, is weight move times distance of added weight to the original center of gravity that in the horizontal direction. So weight move, the weight is 50 tons. Okay, 50 tons. Okay, so 50 tons. Move 7 meter in the X direction, in the horizontal direction, divided by the total displacement 7,500. And this is this one. 550 times 7 divided by 7,500. So 0.047 meters. And Y is in the vertical direction. It will be 50 times 11 minus 5.8 because this is 11. You minus the 5.8, the original kg. Okay, so the height from here to the center of gravity is only 11 minus 5.8. The distance from here to the original center of gravity in the horizontal direction is 7 meter, which is already given here, because G was originally on the center line. So you get the Y, you get the X, yeah. So when we talk about kg and vertical location of the center of gravity, we talk only in the Y direction. So increase in kg only considers the vertical movement of G. That means Y. So what we want to know is how high this D has moved up. All right. In this case, it is the Y. So Y we have calculated just now to be this one 0.35. So kg new is original kg 5.8 plus 0.035. Therefore, the new GM is km. Okay, km minus 0.465. So that is number 8. which is calculation. Okay, I put a note here also. I like to know, because I see in your exercise that you do, or the quiz and so on, always use not more than 3 decimal places, unless you are sure. For example, you are talking about measurement in the centimeters or in millimeters and so on. That's different. Then you convert into meter. Then you may need to use even up to 4 decimal places. But normally we use 2 or 3 decimal places only, because this one, if you use computers and calculators, it can give, and do right answer like this. Always reduce it to just 3 or 2 is acceptable. Yeah, this is not only for here. When you do your experiment, when you go to the lab, when you do your report later for your floating structure competition and so on, please do not use long decimal places, many decimal places. Just use 2 or 3. All right. Normally that's what we use. Okay, so that's number 8, and that's basically the end of the one that is in the Excel. So there's some changes in this Excel. I'm going to share again the new one, because of the two mistakes that we spotted just now. So you go to the other questions. I just go through very quickly what the other questions are. So this is number 6. This is number 7. So number 7, the one with number 8, that the one we did just now. Okay. This number 9. Number 9. A ship displacement 3,000. She then loads 5,200 tons of cargo. Find how much cargo, that cargo having kg of 10 meter may be loaded if ship is to complete loading with a positive GM of 0.3 meters. So this one again, it starts with positive GM 0.3. All right. So and then by assuming that Km is constant, which is not exactly true, but it's okay, by assuming that Km is constant, then you know what's the expected kg, right? So you know what's the expected kg. So you have that table again. You can make the same table like this one. You already have the kg, this one, dm to be 0.5. What was the value just now that they asked? Okay, 0.3 meters, right? But one of these, you don't know the height where it is going to be added. Okay, sorry, how much? How much that cargo having kg 10? You know kg, maybe loaded if the ship is to complete loading with a positive of km. So you have a table like this. You set this one to be 0.3, right? You load everything, but there is one cargo that you don't know how much. So this is the x that you don't know. All right. So of course you can make a formula such that this plus, so this you know all this, and you know this height. This height is given as 10 meters. Yeah. This one is 10 meters, for example. So this is loaded. Okay. For one of these, okay, just change it. You load a cargo, for example, that cargo, you put whatever that has been given, and then for that particular cargo that you don't know, you don't know yet. Okay. So you do x. Do you know that it is 10 meters? Okay. So your purpose now is to find what is x such that the final value at the GM is 0.3. Of course, by doing this calculator, using Excel will not happen. But what you can do is you just sum the rest, and you plus this x times x, 10 times x, must be equal to the final moment minus that. You get the center of gravity, and finally kg minus that. You should get that, right? So it's just a different way of instead of finding the GM at the end, now it gives the GM at the end and asks you to find how much that cargo is to be loaded. Okay, so that's number 9. Number 10 is similar to example, the previous example about the weight going up, which is I think number 5 or number 6. this one, that we finally get minus here, right? But the question deals with derrick. So we have a derrick here. It is required to move 50 tons already on the deck using the ship derrick. Derrick head is 13 meters above keel. So the question is exactly similar just now, except that the movement is from deck 6 meters. It moved to 13 meters. So it is almost exactly this one, right? Except this movement, sorry, this location, okay, although it is somewhere up here. So the location here is 13 meters. And original location was something like, I forgot, here. So it was originally on the deck, 6 meters. So the movement is actually 13 times minus 6, yeah? So it is 7 meters. So it is very similar to this one, except that we just need to understand that for a derrick or for a crane, when it is lifting, yeah, when it is lifting, then the weight is as if being transferred automatically to the derrick head or to the crane head or the point of suspension. And that point in this case is 13 meters. So the question is it safe to do so? You can comment like this one. Yeah, so the movement away and so on. So in this case, it is negative. I think most probably your calculation here is also going to get negative or very small GM. Right? And then number 11, 12, and 13 are just very similar. They're talking about ship tank, okay, tank, and calculation of free surface correction. So that's why the question is, there is find GM fluid when free surface exists. So you calculate the I, okay, and then find the free surface moment and free surface correction. For this is two fuel tank in double bottom, 20 by 5. So question 11, 12, and 13 are all related, yeah? Question 11 is like this. Okay. I think I will, otherwise I'll have problem. Let me say first. Okay, we have few minutes. Okay, I add question number 12, 11, 12, 13, yeah? No. Okay. I think a completely new sheet. Right. So the first question is, so there is this chip here. We don't know how the shape of the sheet, okay? But on it there is a tank. Okay, the tank like that. I see. So okay. So the length of the tank in question number 11 is 20 by 5. Okay, so this is 20 meters, and this is 5 meters, and this is 5 meters. Because there is actually 2 tanks here. Oh, I see. It's okay. Good. Sorry. There is 1 tank and 2 tanks. So, so this is 5 meter. This is 5 meter. So you can understand. So that is question number 2 fuel tank double bottom rectangular shape, each 20 meter and 5 meter, containing bunker fuel, 900 kilogram per meter cube. So you have a tank like this. In the second question, the question number 12, it is similar, but this is only one tank. See, the tank area is still the same. Tank surface area is still the same. Yeah, but this one is 10. So you calculate the second moment area here. And in the third question, it is the same, question number 13, last question. You have similar tank, the same tank, but now it's divided by 3. This will be 3.333. Something like this. So there are 3 tanks. This is one tank. One tank. This is 2 tank. Oh, I cannot do this because it's supposed to be same, this one. So that it becomes 3.33, 3.3. So that means the distance is still 10. Supposed to be 1/3, 1/3, 1/3. So okay, can we do this? Right. Still the same, total still 10. Like this is just so now you calculate the I. Yeah, so with the I, oh, somebody's joined. Sorry. You calculate the I, and with that, the moment, you see the moment for this one is very big because there is no bulkhead in this direction, no walls. Okay, so there is, like this, there's 3 separate tanks. This one is only one tank. The first one is there are 2 tanks. So the second moment of area in the transverse direction for this one is B cube is 5 cube. Yeah, LB cube 112 times 20 times B cube, which is 5 cube. And there are 2 tanks, so times 2. Like this, you have only one tank. So it is 112 times 20 times 10 cube. And there is only one tank, so there is no multiply by 2. Like this one, it is 112 times 20 times 3.33 cube. And you have 3 tanks, so it will be 3 tanks. So times 3. So you have 3 tanks. And with that 3 tanks, you can see that the total second moment of area for this is much smaller than the 2 tanks, okay, and also for the 1 tank. So that is basically the solution to the stick. I'm going to make the solution and later post it to you as well. But for now, you know how it is done. Now I open if there is any questions or comments you want to ask. I don't know whether you can talk. I mean, you can actually say something, or you can when you want chat. You want to write on the chat also can, if you want. So any question or anything you want to add? I'm going to I'm recording this. So again, I'm going to put this on YouTube for you and your friends to revise if you want. Are you okay? Okay. You do not have any questions. Again, you can ask in WhatsApp, either in the group or personally. You can ask me if you want. Yeah. All right. Okay. We are going to have our test in the 3rd week or the 4th week of June. That's our second test. So I've not decided, depending on whether I'm going to check for everyone who's not doing like this. They couldn't attend this class for one reason for the other. Whether are they watching the YouTube lecture, or whether they are. I'm going to have a short quiz again on Google Form to check whether everybody had understood what is done before we do the actual test. Yeah, the actual test we do later, but I'll just make a simple quiz for you to just to check your understanding. Yeah? So the quiz is actually for learning, not really I want to test you and penalize you and so on. So I always ask people to make sure you read everything and try to understand, then only do the quiz. So it's basically to check your understanding. All right. So if there is none, I want to stop here.